pretty good. There was no real problems with question 5. So things to highlight are, for the first part of the question, there's a smooth plane, so you can ignore any friction. And the 2 kilogram block is accelerating upwards. So you know that the whole system is going this way, and this one's going this way. So write down an equation of motion for the 2 kilogram block. So F net equals ma T1 minus 2g equals 2a. That's like 3 marks. So part 2, I just did the same thing for the other blocks. So this is the 3 kilogram one, this is the 5 kilogram one. So for the 3 kilogram block, if we resolve the weight force, this would be 3g sine theta. And if we do that for the weight, the 5 kilogram block, it would be 5g sine theta. So for 3 kilogram block, the total forces would be 3g sine theta minus T2 equals 3a. And for the 5 kilogram block, since it's going down still, it's 5g sine theta minus T1 equals ma, plus this one as well. So this is 5g sine theta plus T2 minus T1 equals 5a. So show that A is this. We have 3 equations from before. So we have the first one, which is from the 2 kilogram block hanging on the side. I rearranged it to find T1 plus 2g, and second one is from the 5 kilogram block, T1 equals plus 5g sine theta minus 5a. You can use any of them, but since we want to find a, we have to get rid of T1 and T2. So first, you get rid of T1. I decided to get rid of T1 first, just so I could use this equation and look simple to start with, in case like the question gets complicated or something. So, but yeah, you just equate it. Five g sine theta minus 5a, and simplify it, so 2g. And then from the 3 kilogram motion equation from the previous page, you can let T2 equal 3g sine theta minus 3a, and you can sub that into here. And you get, if you simplify it a bit, you just get this, and then you can kind of see that you've already got your answer, and you just get what they ask you to find. So find the angle for the system to be in equilibrium. So if it's in equilibrium, then F net equals 0. And if F net equals 0, then A equals 0. So it's handy because we already have A and theta together with no other variables. So A equals G on 5 for sine theta minus 1. So if you let A equals 0, therefore 4 sine theta minus 1 equals 0. And then sine theta is just equal to half. Then if you put that into your cas, you should get something like 14.5 degrees. So now the thing that's changed is it's a rough plane now. So there's friction, and they've given you what the angle is this time, and there's no strings, so there's no tension forces. And the first friction force is 0.1, and not the friction force, coefficient of friction is 0.11, and the second one is 0.01. So to use those, part B is kind of just tells you what to do. So first you draw the weight forces. Wait, 5G surface. I'm using R. I usually use FN just because the other question had R. So I'm just sticking. Oh, they had R and N. I'm just sticking to what they had. And yep, so now there's friction. Since like if you have weights on the surface, they're likely to go this way, so the friction would be opposing that motion, so it's going up. FR1. Yeah, and so that's all of the forces. Calculate. So to do this, you just have to use F net equals ma. So for the 3 kilogram block, if we look at the diagram, so this is 30 degrees. So they would have the weight force part that's parallel to the surface. That would be 3g sine theta. Theta is actually 30, so it's pretty much just 1.5 g. And same for this one. But the friction force would be 0. For the 3 kilogram, it would be 0.01 R, but R is also the perpendicular component of the weight force, so that's cos of 3G cos 30, and same for this one, except it has a different coefficient, so 5G cos 30. So if we use all of those in our equation here, 3 kilogram block is 3G sine 30 minus 0.11 times 3a. And then you can kind of see that all the threes care that the acceleration is not dependent on the mass right now. But yeah, g is just 9.8, and you can just put that into this to find acceleration, because nothing else is unknown. And then you can just sub g is 9.8. Last part of the question, so calculate the time it takes for the 5 kilogram block to collide with the 3 kilogram block, and then give your answer in seconds to the nearest 0.1 seconds. So if they're gonna collide, then they're the same, like, so this is the 3 ones, the 5 one. So if the 5 kilogram hits the 3 kilogram one, then they'll be at the same spot, kind of. So the distance from here to here would be what we're trying to find. So, but to do that, we have to add, or like, so how do I explain it? So basically, so this is the distance at which they will collide, but 3 technically didn't start at where 5 started. So we're going to add 3 meters to 3's displacement, because that's what we'll find, because they originally started 3 meters away from each other. So I think it'll make sense when I explain it, hopefully. So we have our displacement equations for the 5 kilogram block. Is we have u equals 0. We don't know v. We don't need to know v. We don't know time because we're trying to find time, and s is what we need to use our equation for, and a we found in the previous equation question 4.82. So what we're trying to do is we're trying to equate the two distances of the blocks together. We don't need to do anything to the 5 kilogram block, so I'll just write displacement is ut plus half at squared. That's the equation without v in it, so u is 0, so I'll just exclude that. Half at squared, but a is 4.82, so that's for the 5 kilogram block. For the 3 kilogram block, it's the same thing, except we have a different acceleration. A is 3.97. So the displacement of the 3 kilogram block is still 3.97 t squared, but the distance from this point would be its displacement plus 3 meters. So that's why we add 3 meters to this. I'll just rewrite it as distance from 5 kg block. So half 3.97 t squared. And then when these two collide, these distances will be the same. So the displacement of the 5 kilogram block will be the same as the displacement of the 3 kilogram block plus the distance that they were originally apart by. So it's half 4.82 t squared equals 3 plus half 3.97 t squared, and then you can just put that into CAS and solve for t, and I got 1.88 seconds. Wait, no. That's a different question. I got 2.66. Oh no, is it type? And yeah, that's that question.